Hello guys, now we are going to, I will explain to you the ideal gas law in our science grade 10. But first we need to do, what is the ideal gas law? Ideal gas law interrelates volume, the capacity, the space that the gas occupies, the temperature, the energy that is in the gas, the pressure, the force exerted, number of moles on or the how many molecules are there in the sample. The formula that are gonna be using is pressure pressure multiplied by volume is equal to N, the number of moles. R is the universal constant in which I will be explaining to you later, and then temperature represented as T. So if you can see this, this will be our equation. If you can understand my writing, you will do this module. You see, this will be able to help us. Now, what is R? R is the universal gas constant, of which there are three values of R. As from the module said, we're gonna be using, it depends upon the given, but if we do know, but the metric system uses this 8.314, and also so it will just depend on which of the three we will use, depends on the problem that we are to be given later. You get my point. Now, for example, there is an example problem. I don't know why, but still. Now we are not going to explain the problem. I'll just give you the given because it's much more easier. So given is we have to elaborate the 5 variables in there, of which are recap, pressure, volume is equal to number of moles, which is N, small letter, capital R, the constant, and T, temperature. We are given V, P, R, T, N. Now, in this problem, as you can see here, this is the problem. It's inverted because I'm using from the camera. I don't have standard. Our volume for today is 10 liters. Our pressure is 1 atmosphere. And our R weight, we're gonna have to explain later. And T will be 273 Kelvin. In temperature, we always use Kelvin. Always. If it's in degrees Celsius, you have to add it by 273. Gets? Okay. R will be, I will explain to you what the R will be. R depends, as I said, depends on the given of pressure, of the pressure, just the pressure. It depends if it's atmospheres, kilopascals, and millimeters of mercury. Now, in our given, as you can see, this is what atmosphere. So we will use the R, the value of R that has the units in atmospheres, which is 0.0821 atmospheres multiplied by liters over mole Kelvin. As you can see there, my God, you can see there, you see. Now with this, and now so that means we are finding N because N has no value. Now if we have to plug in, since we have to derive the equation, as you can see this is our equation. But since we need to find N, what we have to do is to just divide them. Since we are finding N, we have to eliminate R and T from this side of equation and transfer it to the other by means of division. Here, we're gonna divide both sides by RT so we can eliminate this. So we have to divide. So that, and then RT will be here. You can see RT will be here in this under. That means the formula for the number of moles would be PV, pressure and multiplied by volume, over R, the constant, and temperature. Now we just have to plug in the, we have just to substitute the variables using with this given, which is the pressure is 1 atmosphere multiplied by the volume 10 liters, as I said, over the constant. Just like what I said earlier, the constant is this. Also, the constant also depends on stable. We just have to copy this constant, which is 0.0821 atmosphere liters over mole Kelvin multiplied by temperature is 273 Kelvin. This will be our, so this will be the look of the equation now. It's inverted but still quite hard. We almost stand. Yes, very hard. Yes, very hard. I'm gonna fix this next time. So we just have to multiply using this result, and you need to use calculator because it's very hard to multiply decimals which have big value. It's freaking hot in here. So but first, before we multiply, we must first cancel since k is under k. This always the elimination method is numerator and then denominator. Since this is k, this will be eliminator. Get my point? Yes, good. You multiply, okay? Just eliminate the things that remain. So that means we are only left with more. But this is good because this is the thing that we need to find. Now 1 times 10 is basically 10 over 273 multiplied by 0.0821. As you can see from this calculator, we get the answer. It should be our denominator, which is about 22.4133, and then next is divide 10 divided by the answer that I just saw. That means that our n would be, based from this, is 0.44, round off to decimals, either 0.446 or 0.45 moles of the gas which is stated in the problem is helium. As you can see, I just did the problem solving from this, and from mine we got the same answer. So that is the ideal gas law in basics. That's just it. Okay, bye.